Welcome to this Camtasia lecture about an overview of the endocrine system. So, whenever the word endocrine is mentioned, what comes to mind is, of course, hormones. Hormones, the origin of the word comes from Latin, which literally means to urge on, and that's exactly what hormones do. Hormones are chemical messengers that are produced in one part of the body, circulate through the bloodstream to affect a target organ or a target cell to perform a certain function. So I'm not going to go through this teaser, so we go through it in class. So the endocrine system is composed of various glands. These glands secrete hormones. The hormones are chemical messengers, so if the body needs to have another target organ or target cell perform a certain function, they secrete hormone. Technically, endocrine system or the endocrine glands have 5 general functions, the most important of which is the maintenance of internal homeostasis. As you know, without maintaining internal homeostasis in response to internal and external stressors or demand, survival would not be possible. That's why it is extremely important to have a well-functioning endocrine system. Hormones, again, share general traits. They have specific rates and rhythm of secretion. For example, some hormones are secreted at night. The example is growth hormone. Some are released early in the morning, and the example is cortisol. Some of the hormones are secreted in a pulsatile and cyclic pattern. The example that comes to mind is insulin, because either we are eating or not, there is always circulating blood sugar that needs insulin to be absorbed in order to be absorbed into the cells. And once we eat a large meal, our sugar, of course, is going to rise, and we need to meet it with a bolus of insulin. Some hormones are secreted in a pattern that depends on circulating substrate, i.e. calcium, as in the example of calcitonin and parathyroid hormone. Most of the hormones operate within or with a feedback system. That's the most common one. The not that common is the positive feedback system, and the example that comes to mind is oxytocin, which is responsible for the intensity of contractions when a female is giving birth. So the higher the level, or the higher or the more or the stronger the contraction are, the higher the level of the oxytocin is going to be, and so forth. The higher the oxytocin level, the higher the contraction until the baby is being delivered. I'm going to talk about the negative feedback in the next few slides. Hormones only affect the cells with the appropriate receptors. So in order for that hormone to have a certain effect on the target cell, they need to have the appropriate receptors. There are a tons of hormones. I can't remember the exact number. It's in the hundreds, but we're only going to focus on the most important ones. Again, this is an example of the negative feedback system. For example, when an individual is facing a stressor, be it internal or external, the brain picks on it, the hypothalamus pick up that stimulus, start releasing what is known as corticotropin releasing hormone. So corticotropin releasing hormone goes to the anterior pituitary and basically order it to make ACTH. And then ACTH is of course released by the anterior pituitary, then it circulates through the bloodstream, then goes to the adrenal cortex to urge it to release a high level of cortisol to meet the demand of the stress that the body is encountered with. And as the level of the cortisol rises up, it rises up in the bloodstream. Receptors in the anterior pituitary, receptor in the anterior pituitary as well as the hypothalamus pick it up, and basically they turn off the switch. We don't need any more cortisol, that we are now dealing with the stress. The stress is almost over, so we need to turn off the production. And as the level of the cortisol is higher, the level of the CRH and ACTH goes down, and once the level of the stress goes away, the cortisol turns off, and CH and ACH turn off as well. I'm not going to spend a lot of time about the division, so I'm just going to skip to talk more about specific and concrete examples. At the top, or the master gland of the neuroendocrine system, is of course the hypothalamus. So the hypothalamus is, as its name indicates, it's below the thalamus. It's right here, and right below it is the pituitary gland, which is actually sitting in this bony structure that's called the C tersica, and I'll show you an example. The hypothalamus is basically the master of the neuroendocrine system, because it, of course, in addition to secreting directly two important hormones, namely ADH and oxytocin, it does release some hormones. It's called releasing/inhibiting hormones that actually control the function of the anterior pituitary, which secretes a lot of tropic hormones. Those hormones basically, those hormones affect almost every body function. So that's why the hypothalamus again is the master neuroendocrine organ, if you would, because it affects or it controls the function of the anterior pituitary and releases its own hormone as well. And then again, where the hypothalamus, where the neuro and the endocrine system meet, it's called the hypothalamus pituitary axis. It's an extremely important axis, again, because they work together to maintain homeostasis. The hypothalamus is the center of homeostasis, as I mentioned. It is at the base of the brain, and again, it releases two important hormones, ADH and oxytocin, antidiuretic hormone and oxytocin. I'll talk more in detail when I talk about the disorders. These hormones are synthesized in the hypothalamus, and then they move onto, and then these hormones basically move onto the posterior pituitary for storage. So the posterior pituitary does not synthesize ADH and oxytocin, it only stores them. The pineal gland, I'm not going to talk about it. The reason I put it here is because pineal gland secretes melatonin, and we need melatonin for the sleep-wake cycle. Now we talk in more details about the master gland, which used to be the masters before we discovered that it's actually the hypothalamus is the masters. So the posterior, the pituitary, oh my god, the pituitary is located right here below the hypothalamus in this bony structure called the C tersica, which translates into the Turkish saddle. And I'll show you a picture of a Turkish saddle right here. So they used to call it the master gland because they were picturing it as a knight that is sitting on its C tersica, on its horse, controlling all the body function of the body, all the bodily function, because through the release of some tropic hormones. Tropic hormone means it's a hormone that affects the function of another gland or another organ. So, an example. Again, before I give the example, I'm just going to review. At the top here is the hypothalamus. Below it is the pituitary, which is split into two halves. They are adjacent but completely different parts. The neurohypophysis, or the posterior gland, it's basically an extension of the hypothalamus, and its function is basically a vesicle for oxytocin and ADH. Now, the anterior pituitary, or adenohypophysis, adeno means that it is a true endocrine gland. That's exactly what it is. Look, it says here it is made up of endocrine cells. So endocrine cells secreting hormones. It secretes a number of tropic hormones. One of them is thyroid stimulating hormone. The other name is thyrotropic hormone. So TSH is a tropic hormone because it affects the function of another gland, namely thyroid gland, to secrete T3 and T4. ACTH is another tropic hormone. Let's split it up. So ACTH, A, adrenal, C, cortex, tropic hormone. So it is a hormone, a tropic hormone that affects the function of another gland, namely the adrenal cortex, to secrete cortisol. Follicle stimulating hormone and luteinizing hormone is two other tropic hormones. I'm not going to have you responsible for those. And then prolactin, I'm not going to have you responsible for those as well because you have studied those in previous classes. Growth hormone is not a tropic hormone per se because it doesn't affect certain specific cells, but it affects all body cells, if you would. So, in summary, the master of the endocrine world is the hypothalamus because it controls the function of the pituitary gland in addition to secreting two of its own hormones into the bloodstream, namely oxytocin and ADH. The pituitary is split into two halves. The posterior pituitary, also known as neurohypophysis, which stores oxytocin and ADH. Anterior pituitary is a true endocrine gland, that's why it's called adenohypophysis, and it secretes a number of tropic hormones, namely thyroid stimulating hormone, which affects or controls the function of the thyroid, ACTH, which controls the function of the adrenal cortex, growth hormone, which basically affects almost every cell in the body. Okay, the thyroid gland. The thyroid gland are basically two encapsulated lobes connected by an isthmus. Again, it is regulated by input from the anterior pituitary through the release of thyroid stimulating hormone. It secretes two important thyroid hormones, T3 and T4. Actually, we have all the way to T10 and T7. The numbers here next to T3 and T4 are the number of iodine rings that are attached to this hormone. T3 is the T4, I'm sorry, thyroxine is the precursor to T3, which is the active form. So all the body does is T4 is circulated. It functions as a reservoir. So it's circulating throughout the body. If the body needs more active thyroid hormone, there is an enzyme in the bloodstream that takes one iodine ring from the T4 and becomes T3, and that's basically it's more potent because it's in the active form. Iodine, extremely important to remember that iodine is needed for the synthesis of these hormones, and the thyroid gland is almost the only gland in the body that uptakes iodine. What does the thyroid, why do we need a thyroid gland? Because the thyroid hormones are extremely important for life. There is not a single cell in the body that doesn't use it. Because, I'm going to summarize it in one big word. It is responsible for metabolism. Every cell needs to metabolize. That's why you need thyroid hormone. So bear in mind that without thyroid, there is no metabolism, and without metabolism, basically dead issues. That's why we cannot live without thyroid hormone. Thyroid hormone is also implicated in the maintenance of blood pressure as well, because we see some patients when they come into the hospital in myxedema coma, they actually drop their blood pressure as well as they go into respiratory failure, because again thyroid hormone is responsible for the uptake of O2, and every cell needs to metabolize to the respiratory cycle. Again, the word metabolism implied this carbohydrate and lipid metabolism. And then another extremely important function, especially for children and newborns, it is extremely important for brain function and nervous system activity, and growth hormone and growth and development as well. That's why almost all states in the US actually perform a thyroid level when the babies are born, because it's extremely important to make sure that they're gonna develop, that their brain function is gonna need thyroid hormone. We want to make sure that thyroid hormone is available for these children. Otherwise, they are not gonna develop both at the level of their brain as well as their somatic growth. How do we assess the thyroid gland? We assess it. The most common one is the posterior method. So In the posterior method, you stand behind the patient, you place the thumbs on the back of the neck with fingers, and you ask the patient to swallow. And then when you swallow, the vocal box goes up and displaces the thyroid, and you'll be able to palpate it. However, I must tell you that it's to palpate a normal thyroid gland is extremely difficult, and when you are able to palpate it means that it is abnormal, and you need a very tactful clinician to do it. Okay, and then before I close this presentation, I have to mention that actually the thyroid gland is also responsible for the release of calcitonin. Calcitonin is released from follicular cells, while the follicular cells secrete thyroid gland. Again, you have to remember, calcitonin is not secreted by the parathyroid cells. It is secreted by the thyroid gland, i.e. the peripheral cells. And what is calcitonin responsible for? It is actually a weak regulator of calcium. It is released in response to high level of serum calcium. So when serum calcium goes high, we release calcitonin, and then its main site of action is on the osteoblasts. So it actually urges the osteoblasts to take away that excess calcium from the serum and lay it in bones. That's why calcitonin is important for good bone strength, and we usually prescribe it for people with osteoporosis. It also decreases it also decreases serum calcium by increasing renal excretion of calcium and phosphate. I'm going to end my presentation here, and I'll meet you in the next presentation.